The brief for this was to talk about my career as an academic, which is only part of my career. I've also spent time as a government administrator and as a consultant. So there's a range of background there and it has covered some of my thoughts. The title itself was data everywhere, not any drop of information. And for those scholars amongst you would recognise the similarity to the rhyme of the Ancient Mariner, a water-related poem written many years ago. Water, water everywhere, not a drop to drink. I was never going to call it papers, papers everywhere and not a drop of information, because that is to a certain extent how academia has progressed over the last 30 odd years that I've been involved in. Even to the extent that last week, it was last week, when I was in Lisbon for an IWA publications meeting. The concern over all of the journals they're publishing are the papers they're receiving and what is unique in those papers, what's innovative in those papers, what is contributing to available knowledge. But I'll come back to that. When Philip asked me to prepare some questions, get to know your fellow academic, there's a range of interesting questions and then he asked for a photo. I came very close to giving a different photo to the one you saw, and that actually related to one of my earlier careers. For many years, particularly while I was studying at university for my bachelor's degree, I was also playing professional football. And Hardy mentioned my work-life balance. I'm still a football tragic. Some people have recognised the cufflinks I wear regularly with shirts. They are Sydney FC cufflinks, but that's not the true love. Used to play for a club called Newcastle KB United. KB, for those of you who are not old enough to know this, used to be a regular beer drunk. Nothing like being sponsored by a beer company. But let's move on. What is different with my career to the current trend, where we go to university to then get the PhD scholarships you need to study the PhD? You generally jump straight into that research program. You have not had the experience of working outside and finding out where some of these problems exist. What are the problems being encountered by the 95% of the profession who work outside academia? What are their research questions? And that is the biggest difference between when I started in my academic career and current requirements. There is also another big difference in that, and I've also actually started in Canada, my academic career started in Canada at the University of Alberta. And if anybody knows the University of Alberta in Edmonton, anybody who can survive a Canadian winter in Edmonton deserves every degree they obtain. You think it's cold outside? Go to Edmonton. It never gets above -10 all of January. Minimums are getting close to -40. The importance of -40, by the way, is that's where the Fahrenheit and Celsius temperature grades coalesce. it's not cold. This is not cold. But an early experience in American, Canadian universities also highlights the difference between a lot of Australian PhDs and international PhDs. A lot of their PhDs are based on industry-sponsored direct research into a problem. One of which I was involved in took us into the Arctic Circle, collecting water samples to work out where the plume from this, I guess you'd call it a treatment plant, if you could call it a treatment plant, where that plume went into the Mackenzie River. Now, the reason we had to do it in the summertime was because you can't do it during the winter. Remember, I just said summertime. We're drilling through 1.5 meters of ice 4 times a day so we could get to the water in the river. Also demonstrates one of the unique properties of water. It freezes from the top down. So you can still have fish and everything living in those rivers. But we only needed daily samples, but we were still taking went out and drilled 4 times a day because those holes would seal up in that time. Taking water samples was interesting. The town existed because of gold originally. It was on the gold trail from Alaska. But now because of oil. There was an oil pipeline going through the area. The project itself was trying to replace the existing macerator treatment plant with a more advanced treatment plant that would work in cold weather. As I said, it's cold. You didn't want to drink too much. And the reason you didn't want to drink too much was because no utilities are buried in the ground like they are here. Everything runs above ground because the ground is permanently frozen. So they're running utility doors. And you have to continually step over these corridors of utilities. Drink too much and you miss your step. I also experienced there a unique summer festival. Ice, snow everywhere. But if you have a summer festival, what must you have? Girls in bikinis. They had a summer festival parade. They had a truck with local Inuit girls in bikinis on the back of a truck. And you think it's cold. The local indigenous population there, by the way, are Inuits, which are a mix between the older Indians and the more recent Eskimos. But they are their own individual race. But that sort of introduces a different scope. You had to answer a problem. It wasn't just about doing the research for publication. It was about solving a problem, and you had to produce reports on those problems. That is a different sort of training, but also very consistent with the American style of publish or perish, and they do count those reports as part of your publication. Moving on from that, I've always been playing around with models. Even in my government days, I used to play with models. My wife prefers the computer models. sometimes I think, yeah, it'd be nice to play for supermodel, but I can't afford them. Very bad pun. Very bad, very poor taste of the whole lot. But models, and that brings you to a whole range of different concepts. When we first started playing with models, building our own models, etc., we actually believed in those models. But we now know all models are wrong. Some just produce useful information for decision making. And that's the important bit. We take a lot of data. We use models of different type to mine the information out of that data. If the models are not appropriate, you don't get any information, which you can then apply. And you'll see that throughout, and those concepts coming through a progression of papers that have been written. The mention was 30 years old paper. The paper was actually published in 1985, and I was contacted 2 years ago by people from the US EPA. They are currently rewriting the X-strand component of SWIM 5, which is the current model. And they're wanting to use that paper as one of the foundation concepts for development of that new software. The fact that I've moved on from that, most of my colleagues have moved on from that, but it's still relevant to industry, is something that I wouldn't say I'm necessarily proud of, but I'm also very thankful for that opportunity for it to occur. It shows, in my mind at least, that there was a need for that work. It shows the longevity of that work rather than looking for the instant sugar hit of something being accepted very rapidly. It shows the development from concept into practice, and that is something to remember. We do a lot of research in universities. We don't do a lot of development, and there's a big difference between research and development. Putting into practice the things we research takes more effort and more time than researching the new concept. Okay, moving on from that, as I said, I've been at a number of different universities. As I've mentioned Alberta. I've also spent time at Newcastle, Texas at Austin, and everything they say about Texans is 100% correct. It really is. The day after my wife and I arrived in Texas, they took us on a tour of Austin, stopped in front of the Texas Parliament House and asked us, "Do you notice something?" To which the comment was, "Yes, it looks like the Capitol building." "Yes, but do you notice anything?" "No." "Is there something we should notice?" "Yes, our building is 6 inches taller than the Capitol building." Everything is always bigger and better in Texas. But if you want to go to a university with money, go to Texas. They were, in the early 1900s, they were given the choice. They would take a certain percentage of state budget, very, very small, or they could take the mineral rights in northwest Texas. They took the mineral rights. 10 years later, oil was found. That's a university that's running on oil. The football coach, and this is American Gridiron, was paid more than most of the NFL coaches. Football is very serious over there, particularly when they play Texas A&M, which is only about 100 miles away. Best immortalised in that movie and stage show, The Best Little Whorehouse in Texas, the Longhorns versus the Aggies, and it does get very serious. But after Texas, I've been at UNSW, which Hardy's already mentioned, UTS, and every university is different and unique. They all have their characteristics. The student profiles will differ in all of them, and you can expect them all to differ. However, the expectations in every university that I have been at have remained very similar. And that similarity is the attempt to develop a capacity for the students to think. Not to do, but to think. University education is very much about teaching people how to think about the problems they will encounter. Because the problems we are teaching you about now, in 10 years, will be different to the problems being encountered then. ChatGPT that Hardy mentioned, it was Hardy mentioned earlier, or was it you, Sean? You know, ChatGPT will change those problems again. The how to do something, while it's important, is not as important as the capacity to think. The capacity to dismantle a problem into its components and then to rebuild the solution based on those components. The classical engineering context. It's that disassembling of problems and the reassembling into the bigger solution. And understanding what is important and what's not important. There are many arguments, and I was lucky enough to be invited to be the lead editor of the 4th edition of Australian Rainfall and Runoff, where we developed many practice statements. And there were many arguments in that group of authors and people preparing things on the flood frequency analysis, which mathematical or statistical model should be recommended for use in Australia. If we followed the US, we would only be recommending an LP3. If we followed the UK, we'd only be recommending a GEB. But let's take a step back. All flood frequency analyses are premised on the data available. So we have got a student, and students are good for this. They're cheap, and they do what they're told occasionally. But I had a student from Brazil who went through the Water New South Wales database of their gauging stations. And there's about 1,400 locations where data is monitored on a continuous basis. Now we can reduce that 1,400 down to about 1,100 because 300 of those stations are so poorly documented you don't even know what is there and where the data is occurring. We can further reduce that to 900 on the basis of some of them, the data is so poor that more than 50% of the data is missing. The instruments have been broken. Now of that 900, he then investigated in more detail. Extraction of the annual maxima series, which is the standard process, the highest recorded flow at that gauge, every year over the period of record, suggested that 75% of them had the median of the annual series above the highest flow where they checked the rating. In other words, how much flow would go past that station for a particular recorded level. Now, any hydrographer will tell you the minute you go above the highest gauging, you're in extrapolation territory, or let's make some data up. To tell you how significant that is, we were involved in a study on an unnamed river some years ago. We could calibrate the model to the tidal cycle because it was in the tidal regime of the river. The minute we tried to put any flood data into the river, we could not reproduce the recorded data till we removed roughly 30% of the flow in the recorded data. Then we could get near exact replication of the recorded data downstream from the gauging station. Similar situation, all of those predicted flood flows were in, let's make some data up. To make matters worse, most of that data was extrapolated based on flows within the channel, and if you're dealing with floods, where does that data come from? Generally flows out of bank. So let me come back and make the comment. We're dealing with data that's been made up to predict statistically what's going to happen. How reliable are those statistical predictions? This is where we get data, but no information. There's no information in that. It doesn't matter that this was a statistical model. Exactly the same thing comes when we use the more detailed process models, catchment models. There is a council who shall remain nameless who decided they will run a 2D rainfall on grid model across the whole catchment. That involves something close to 50 million grid cells in their area of interest. Each grid cell has the order of 8 parameters. We're looking at 400 million parameters that need to be identified. Good luck with that. It won't happen. Which brings me to another student's problem where a student helped out. Hang on, 5 minutes? This particular student, we took one of those calibrated grid models for a catchment in Victoria, which had an embankment, a number of culverts and a bridge. But instead of doing industry practice of assigning a constant roughness to the same land use type, we Monte Carlo'd it. So every grid cell had an alternative roughness, but the average of that land use remained the same. Doing that, we managed to find events that would turn off the flow through some of those culverts. Now they might have something like 300 millimetres of flow going through the original so-called calibrated model, and you can vary the roughness and for exactly the same input and have absolutely no water going through those culverts. Once again, you have a lot of data, but is there any information? How reliable is the information? Just because you have data doesn't mean you have information. Now Sean's trying to get me to wind up here so we can all go and have a lunch. So let me conclude by saying a varied career, useful to have the industry experience associated with the academic experience. It gives you a different perspective on problems because you have had then the opportunity to see how the technology and the knowledge that we generate at a university can be applied in practice. And through that, remember the tenet of professional engineering in Australia is we are there to assist the community, to make their life better. So ultimately, our research is aimed at enhancing the life of everybody else in the community. And I hope my career has helped in doing so. Thank you for that, and thank you for the opportunity to give these words.
Any questions?
I thought I was going to get away with that question.